Assessment today in order to simulate what a real world assessment from a company would look like. So let's just do this. So given an n by n binary matrix image, flip the image horizontally, then invert it and return the resulting image. To flip an image horizontally means that the row of each image is reversed. So we just are reversing the list, that is okay. To invert an image means that each 0 is replaced by a 1 and then each one is replaced by a 0. So we first flip it and then we reverse it. That's it. That's nothing really. Alright, let's just do it. Or maybe let's take a second and maybe see if we can approach this a bit more optimally. So the current suboptimal solution that I can just think of is we simply go do a n squared, wherein we reverse each of the ith column of the image and then we simply invert it. But do we need to actually do that kind of flipping and inverting and stuff like that? That is the first question that we are asking ourselves. So you can see that over here we can do a two-pointer approach, wherein we see that there is a 1 and a 0 over here, and these are supposed to get flipped. As you can see, it makes sense, right? So when I'm flipping these two, I know that there's a 0 over here, there's a 1 over here, but the whole point is we don't want to change anything. And if we don't, and that way we can do everything in just one loop. I mean, it's still going to be n squared because we have to go through the entire image, but it will still be a bit faster. And it's just image. And we will also be able to do swapping in place, and that will allow us to save up on the space complexity as well. So we can just do start s equals 0, e equals len of image image 0 minus 1. So while s is less than equal to e, we want to do the swapping and inverting in just one go. So we simply get the basically we can say that if image start is equals to image end, then we simply flip those two. And so if the image I s equals image I e, then in that case we just want to say that if this equals 1, then I want to make that equal to 0 and make that equal to 0, else I wanna it's a 0, so I want to make that 1, make that 1. Otherwise the two are not equal, and in that case I just want to flip the values. So actually no, wait, I don't even want to flip values, I just want to leave it as is, because if you see this, you can see that only when they are, so over here you can see that only when they are equal are we swapping them. So we don't need to do anything now. So this is all we need to do, and since we are doing in place modification, we can just return image, and that should do the trick. I might have maybe missed a couple of edge cases in order to do this a bit better, but I think wait, we made a tiny mistake, I'm sorry. We forgot the update condition. So s plus equals 1, e minus equals 1. Okay, how do we stop this from running now? Okay, is the output correct? I'm not very sure. Yeah, it is correct. So let's just run it on example test cases and see if it works. If it works, then we can kind of go ahead and submit. Yeah, it works, so we can just submit. Perfect. And it works. Perfect. We have a decent solution. So consider all the leaves of a binary tree from left to right order. The values of those leaves form a leaf value sequence. For example, in this case, this is the leaf value sequence. Two binary trees are considered leaf similar if their leaf sequences is the same. So in this case, okay, yeah, so I got the question. The question is relatively simple. It's the implementation that's matter. Okay, so we can just run a DFS through the tree, and basically whenever we are at a leaf, so okay, we'll write the approach down first so that I can kind of uh, so run a DFS, and if node, and if not node dot left and not node dot right, then node is a leaf, in which case append its value to a list, and that's pretty much all we have to do, and then compare the two lists. Oops, lists. So okay, that is all we really need to do. So all I need is a DFS method which takes in a node. So if not node, return, if not node dot left and not node dot right. So this is our condition for the leaf node. So if that is the case, then we want to do leaves, which will be a list, and we want to do leaves dot append the node dot value, and then we just want to do return leaves, and in this case okay, so in this case I just want to return an empty list, and otherwise all I want to do now is I want to run my DFS. So I want to do node dot left leaves DFS node dot right leaves, and then we simply call the DFS on we do R1 and R1 values, or more like R1 leaves, and we call the DFS on the leaves, I'm sorry, on the root 1, and R2L will call DFS on root 2 if R1L equals R2L, return true, else return false. We can have done this in a simpler method wherein we run DFS parallelly through both of them, and then just check for each, and as soon as there is a mismatch we simply say that that there's something wrong or something like that, but that's okay. I feel like even this method is fast enough that it should kind of do the trick. Okay, so this one returns true and that one returns true also, so I think I know why this is the error. I'm just gonna check if that really is the case, and if that is only what the error is, then we are pretty much chill. Otherwise there is some error with my DFS, which is a very real possibility. Yep, there is an error with my DFS. Okay, let's just see what the error is. We are running the DFS, we are appending leaf only if we are only appending if that's the case. Okay, let me actually print out what the two values are, R1L and R2L, because maybe there has to be some other issue because of that. So let's just print it out and get to understand what exactly is happening under the hood. Okay, that's a more different error than what I was expecting. So apparently there is nothing in R1L and R2L for some reason, which is a surprise. Let's just get rid of this big test case and let's just keep a small test case wherein we know it's not equal. So it's still outputting none, so there's some other issue that is happening in my DFS. So if there is no node dot left and there is no node dot right, so we know that this is condition of leaf node. We return the leaves. Are we appending the value correctly, or is it something wrong with that? So if I were to just make something over here, uh, r1 equals that and r2 equals that, this is a very bad approach and I'm just kind of hacking this in there. So uh, r is equals to minus r equals 1. And get rid of this. I think I understood what my error was, but I'm still not gonna, I'm gonna wait for a sec. So if r equals 1, then instead of doing leaves.append, we can just do r1.append and we can just return nothing. That should do the trick. Oh, okay. Use example test cases. Please give me true and false. And why doesn't this work? Okay, cool. So at least we are getting something in our hands. What are we getting though? That's the question. 67498. Oh wait, what? We are making a stupid mistake. I think they should do the trick. What is happening is we are, for some reason, putting everything in just one list. Is that because of this? This could just be the problem. It was defaulting to 1 every time, that's why. And now it works. This solution works, but I am now going to clean it up once we submit. Okay, cool. We won't finish the session yet. We will just clean the code up a bit more. And once we do that, we will then submit. So if not node return, this is correct. Now the problem in our code was the way we were actually doing the appending was the problem, and now we will just go ahead and fix that real quick. So way we will do that is we'll have a thing leaves over here. Now what we will do is okay, wait, let me think. What had I done initially? I forgot to store that code. So what was happening was that our leaves was actually just passing out as an empty value, and we did not want that. I mean, yeah, all I need to do is really just do a leave startup and here and make sure I'm returning that. You know what? For now, I'm just gonna let it be. This is all right code. Uh, let's just submit. See how we did. Oops. Finish session. I mean, we did pretty badly to be honest, but still, probably be in like the top, I guess, 50%, because I'm pretty sure no one should take more than 13 minutes to solve this stuff. I mean, if they are practicing. Whoa, I did better than what I thought I did. Uh, but I mean, still kind of average only. Like, these are the outliers. But I mean, whatever. This is what it was. Uh, I'm not that happy with my performance to be very honest, but I mean, I'm assuming that if I would have done this in a phone interview, like the online assessment round, I might have advanced to the real thing, like to the phone interview. I think I might have, or maybe not, because maybe they'll just pick like the top 10%. I don't know. It really depends on a lot on what the company is considering and stuff. Because if they are looking at code, then I'm pretty sure I'm not advancing. Although I feel like our flipping an image code was decent. Yeah, because I feel like the way we did flipping an image, it was a decent method. Like it was, I know that they were expecting that, so it's not like we did something that was like really good, but we at least did something in a way that in improved complexity a bit. So let's just show flipping an image. Let's see what how we stand in front of other people. Okay, where do we actually have our solution? Where do I actually get my solution if I want to copy paste or something? Okay, I'll just copy that. Like, is this one of those problems where one solution is always there's that one solution which is always like heavily favored? Let's just click submit and see. Yeah, from what I can see, it beats 100%. So yeah, but we did have a good memory usage, so beats 89.17% on that. To be honest, yeah, because we are doing it in constant that, so it's pretty good in that way. And from the way it is, okay, but who exactly? Why would it take this long? Okay, so these people actually did the two things separately, and that's why it took them more time. We did it all in one way using two pointers, so for us it was a bit better. Okay, and then there were some people who used very less memory, so let's just see the way they did it. Uh, Pretty much the same thing that we have done sort of, uh, but yeah. So we have a good solution. Like when I look at this solution, it's a neat solution, so I like it. Not something I can say about my binary tree solution, but still, a solution is a solution for now. And it's not like our tree solution was bad in complexity time, like time complexity. It's not like when we did that we worsened our time complexity. No, the runtime was the same. It's just that we were like I was making those stupid mistakes and stuff, so I just kind of hacked in my solution there. Okay, but whatever. This is what we have done, and I hope you enjoyed the video. If you want to try out some contests like these ones, not contests, but like sample interviews and stuff on like this one, then you can make an account on LeetCode and do that yourself. And let me know how you do. You cannot cherry pick which questions you will be doing, so you probably will get a different question set from mine. But yeah, So that's it for this one. If you liked it, like and subscribe, and I'll see you in the next video. Until then, bye bye.